Okay, so we'll start with the most obvious part, the steel. Normally you wouldn't think that choosing a material for a steel bridge would be that complicated. I mean, it's steel. Aren't we done with materials then? Well, it's a little more complex than that. Steel itself is an alloy, but there are many unique combinations of the elements in steel which create different distinct alloys of steel with different properties. As technology continuously improves and new discoveries are created, new, improved alloys have been made which people years ago didn't have. Specifically, if you look into the use of steel at all, you're likely to come across something called weathering steel. Corten is a company that is well known for producing this kind of steel, so weathering steel and Corten steel are often used interchangeably, even though not all weathering steel may be Corten. Anyway, Corten steel is pretty special because of a unique trait that has caused it to become quite popular. You remember that chemistry question on that one AP practice test about steel that only rusts on the surface? Yeah, well that was Corten steel. Mind blown, right? Okay, focus. So one of the main ways Corten steel differs from conventional steel is it contains more chromium, copper, and nickel, and if you remember, the additional chromium reacts with oxygen at the surface to form an oxide, or rust. This rust forms a layer that covers the surface and gives Corten its main advantage, a protective layer of rust that prevents oxygen from reacting with the metal underneath. Normal steel needs to be covered in a protective paint to achieve a similar effect. So with Corten, you don't need the paint anymore since the metal can now protect itself. As a result, Corten steel saves you the money you'd spend on this paint and often corrodes much slower than normal steel, which makes it last much longer with much less maintenance. Acid rain is a common problem for metal structures that needs to be considered. What happens is sulfur dioxide and nitrogen dioxide in the atmosphere reacts with water vapor to produce sulfuric and nitric acid, which are both strong acids that completely dissociate the presence of water. Some nitrous acid is also formed, which is a weak acid. When this acid comes into contact with steel or other common construction materials such as concrete, it causes it to corrode. In the case of steel, a redox reaction occurs where the solid iron in the steel gets reduced with the electrons of two hydronium ions from the acid to produce an iron ion with a +2 charge and hydrogen gas. The polyatomic ions from the acid remain as spectator ions and don't participate in the reaction. The dissolved iron can then be washed away, which causes the steel to deteriorate over time. The hydrogen gas that gets produced can also cause the metal to warp over time, which ruins the structural integrity. This damage can be prevented by protecting the metal with special paints or by using weathering steel. However, damage is inevitable after a long period of time. The water collects at the joints, so those should be given special attention during the maintenance. Salt water is a very similar problem to acid rain that can be especially irritating in beach communities. What happens is salt water in the air, or actual salt water from, say, the ocean, comes into contact with the surface of the steel. The problem is that the saltwater solution makes it very easy for electrons to pass through because of all the charged ions floating around, which is why salt water is a good conductor and pure water is not. So, the result is a system that allows the solid steel to lose electrons and oxidize very easily to turn into ions, which, like acid rain, will cause the dissolved metal to float away and deteriorate the structure. And again, paint or Corten steel can be used to prevent this process, but total salt removal, which would be done with regular maintenance, is really the only way to completely stop it, since even a tiny amount of salt can keep the process going.